Hi everybody, welcome to Test 2 review. This time I try to put as much information on the screen as possible, therefore no face cam. Alright, let's just go straight to the first one. So the first question, or first few questions, deal with trig substitution, and the trig substitution is over here at the bottom right hand corner. Right. So first problem, we have the integral (25 minus x squared dx), and we will rewrite this in terms of theta. So make a substitution and then rewrite this in terms of theta. Make the trig substitution. Then rewrite in terms of theta. Right. So the case here we have a constant square minus x squared. By the way, I will rewrite 25 as 5 squared. Right. And for this, we'll make the substitution. If it is a constant square minus x squared, we will let x be that constant times sine of theta, and then we can check the derivative. Is 5 times cosine theta. Move the d theta over. Dx equal to 5 cosine theta d theta. Right. So we have dx to substitute here. Next we rewrite the 5 squared minus x squared in just one term. X is 5 sine theta square. So 5 square minus 5 square, and then sine square. Factor out the 5 square. One minus sine square is cosine square. So we just have 5 square cosine square, or we say 5 cosine theta square. Of course, we don't have to write all of that step. We can just go straight from here to here, and I mean that. All right. Now substitute back into the integral. Five minus x squared is this. 5 cosine theta square. Dx is this. And we have square and the square root cancel out. So we will have 5 times cosine theta and 5 times cosine theta d theta. 5 and 5 will be 25, and cosine times cosine is cosine square theta d theta. Right. So the answer is going to be sine 5, and here we just type 25 and then cosine. To type the power, we had hit the shift number 6 and then square, and then to type theta backslash theta, we'll just spell it out, backslash and then theta, right? Right, that's it. There's a lot of way to enter this question though. I'll try that in the next problem. You'll see. Right, so that's 1. 2, pretty much we'll do the same thing. Trig substitution, we write in terms of theta. We have x squared minus 64 to the 3/2 dx. Right, here we have a constant. I mean the variable square minus a constant square, that is a squared to the 3/2 dx. Right, if we have a variable square minus minus a constant square, we're going to use that row. So it's going to be secant x be 8 secant theta, and then we will solve for dx. Take derivative. Derivative of secant is secant tangent, and move the d theta over. Right, so that is dx. And then we just need to do the x squared minus 8. Of course, it's going to be a squared tangent theta square. That is at the bottom right hand corner. But I'm just going to do that again. X squared minus a squared. X squared. This is x, a secant square minus a square. We have a square secant square minus a square, and factor out a square. We have secant square minus 1. Secant square minus 1 is tangent square. So we can put both of them inside a square. Right. Turn up the volume a little bit. Right, and now we just substitute into here. Here's this integral bi. So we have 8 tangent theta square and then to the power of 3/2, and then dx is this a secant theta tangent theta d theta. Multiply the power, the 2 and the 2 cancel, end up with just a cube. So we have 8 tangent theta cube, and then 8 secant theta tangent theta d theta. A cube, it doesn't matter, we just say a cube, which is 512, doesn't matter, but we just, and the cube go to tangent, and then times 8 secant theta tangent theta d theta. If you enter this in MATLAB, they certainly will take it as long as it is equivalent, but we should simplify though. A cube and 8, that is a to the 4. We can get the answer for a to the 4th, but like I said, my MATLAB we just take the equivalent answer. We have tangent cube and the tangent here cube times to the first power, so that will be tangent to the 4th power theta, and then secant theta d theta. Right. So we will use the secant substitution with 8. Oops, sorry. 8. And then we can just type 8 to the 4th power. And the tangent to the 4th, if we're not sure about it, we can always type tangent of theta to the 4th power, and then secant of theta. So my MATLAB will take a bunch of different answers as long as they're equivalent to it. It should be fine. Like I said, don't even need to simplify it. Still works. Right, next one. Right, still same thing. We have the integral square root of 25 minus x squared over x times dx. Right. So of course we focus on only the square minus variable square. So we will have a constant square minus a variable square, so it will be that. Right, so substitution is going to be a sine of 5 sine theta, and then we'll take derivative. It's going to be 5 cosine theta. Move the d theta over dx equal to 5 cosine theta d theta. And then the part we have 5 squared minus x squared equal 5 squared minus 5 sine theta squared. It's going to be 5 squared cosine squared, just like the formula that I highlight on the other side. But sometimes just doing this, building some repetition. Five square, 1 minus sine square cosine square. Right. And we substitute that into 5 square minus x square. Right, 5 cosine square right? X is 5 sine theta. Alright, I may enter this problem wrong. It should be the other way around, but never mind. Yeah, I make this problem, so could be wrong. I think I meant this to be x squared minus 25. Square cancel square root. Right, sorry, this problem is, the answer is wrong. All right. Nothing cancel here. We just have 5 cosine square over sine theta d theta. Right. That the answer supposed to be cosine divided by sine. Right. However, it's not going to be correct. I remember I put something else. So I will send out the note. This is you. That's what it should be. That's what it should be, but the answer is wrong. Sorry. When I write that down, I meant to be x squared minus 25, and not the other way around. Right. I said, ignore that. This is the correct answer for that problem. I just make the wrong key. Yeah, this should be x squared minus 25, but I just make the wrong problem. Hi. Sorry about that. Yes, you can see this is a question I created, so it's not my MATLAB problem. It is my problem. Right. Right, now we use the same thing. We have 2x cubed over x squared plus 16. I'm not even sure if this is the way to do it using trig substitution. By the way, let me write. This is the wrong key. I'm not sure if I can go back and change it, since some of you already attempted this already. Right. By the way, on the test, if this happens, just put whatever the answer is. I can always go back and change it manually. Right. Let's hope that's not the case. Right. Now we have a constant square plus x squared by the way, if this is just 2x, this is not trig substitution. If this is just 2x, we just set let u equal x squared plus 16, and then du is 2x dx. There's no problem. But because of the cube, we use trig substitution. Right? Right. Now, constant square plus x squared is going to be that. Right. X equal to 4 tangent theta. So the x d theta is secant square. Move the d theta. Right, so that is dx. And now we put everything back into our problem. See, what do we have? X squared plus 4 square, 4 tangent square, plus 4 square. We have that, plus 4 square, will be equal to 4 square, factor out tangent square, plus 1, which is secant square, or 4 secant. Right. Put everything back into the integral. Two x cubed, this is x. X squared plus 4 square is this one square. Dx is that. Right. Multiply the powers. 2. 4 cubed is 64. Tangent cube theta over 4 square 64, 4 square 16, and then secant square, and this is 4 secant square. Right, secant square cancel out. 16 divided by 64 and 16 cancel out. There's 4 on the top. 2 times 4 times 4, that is 32. 2 times 4 times 4, 32. Tangent cube d theta. Is the tangent 4 tangent theta. This should be x equal to, right? Oh, shoot. Oh. Let me see if I can do this first. Right, this will be x. First, let me stop the video. Right, good news. Good news. I just take a look and nobody attempted the review before, so I will go back and change all the problem. They have to be x equal to and not u equal to. I have to change all the question. But if we do that, don't worry. I mean, and I need to change the key for this problem as well. Not change the key, just change the problem to x squared minus 25. Should be fine. Sorry about that. So instead of u should be x, when you do the problem, there will not even be a problem. Right. At least we do it here so I can see where the problem at. But in terms of the math, there's nothing wrong with it. It's just x equal to and not u equal to. I just make that change real quick. If I can create the problem, I certainly can change it. Right. Now this problem is from Pearson. I'm not changing anything here. Right, 324 look like 18 square to me. It is 18 square. Right. I will just move the x to the back. Right. We write like this, make things easier to do. Right. What we have is a constant square minus a variable square. So let x equal to that constant. This case is the sine theta. Right, take derivative. (18 cosine theta). Right, I hope everything's okay. Because I haven't used much, the computer goes to screensaver. Right. So we have dx. Now we will change this to theta. (18 square) 18 sine theta square . (1 minus sine square). (18 cosine square). 18 times cosine, all of that square. Huh. We've done this many times already. Right, now put back into the integral. 1. Square root of 18 square minus x square. That is the 18 cosine. Dx 18 cosine theta d theta. Right, Square cancel square root 18 cosine theta times 18 cosine theta d theta. Now this problem conveniently it cancel out. The 18 cancel out too. Just have one left. Integral of that is just theta plus c. So just need to find theta. Now go back to the substitution we used before. We solve for sine theta. It's x over 18. And then to get back to theta, it is sine inverse of x over 18. So this equal to sine inverse x over 18 plus c. Sine inverse x over 18 plus c. Right. So once again, the substitution is x equal to for the first 4 questions I say u, but don't worry. And also I'm going to change the key for this problem for number 3. Right. Good thing that I did this before. Right. Next question. Right. Now we're on to section 8.5 partial fraction. We have a bunch of scenarios, but on this problem we just need to write out the form of the partial fraction. We have 7x over x minus 7 x squared plus 1. Right, so we have 2 factors of x minus 7, so we're going to need 2 fraction for it. And then x squared plus 1. 1 factor of that, x squared plus 1. Now on the top, degree is 1 less than the bottom. So this is the first degree on the top, just a constant. Linear factor, the top is a constant. And then this is x squared, so we need an x on top. So degree on top is 1 less than the bottom. And it's look like this one. Right. Next, evaluate the integral. Right. Now, before we go any further, it will be extremely helpful if we write out this integral first. Right. So this is subsection 2 on section 8.5 or 8.5 subsection 2. I will write out these 3 integral because this will be extremely handy. Integral of 1 over x plus a dx equal to ln of x plus a plus c. Right. Now what if we have a square? This is going to be negative x plus a to negative 1 plus c. Right. And finally we have that. This is once again section 8.5 subsection 2. And after all the substitution we have at the end on the back 1 over b tangent inverse x plus a over b plus c. Right, we'll refer back to this. This number 7. Evaluate using partial fraction. By the way, at the moment, this test review is not available right now because I have to make some change because I make a mistake for the problem I created. Just minor things. Particularly the first 4 questions. Right. So this obviously we have a form of the partial fraction, so we try to break this into a bunch of little fractions and then we integrate. So we do the partial fraction. And we have 7 x minus 5 x plus 2. Just have 2 linear factors, so we have x minus 5 at the bottom and x plus 2. On the top we don't know what it is, just a and b. Right. Multiply everything by the common denominator, x minus 5 x plus 2, and that cancel out. We have 7 equal to a x minus 5 cancel out, we have 8 x plus 2, then plus b x plus 2 cancel out, x minus 5. Right, multiply it out, ax plus 2a bx minus 5b, combine like terms. We have a plus b factor out in x, and then 2a minus 5b as a constant. On the left hand side we have 7. Now these two things are equal, meaning the same coefficient of the same degrees. Coefficient of the same degrees must be equal. So there's nothing on the left hand side here that go with x. So we're going to let this coefficient be 0 because there's no x on the left hand side. We do have the constant on the other side equal to 7. So we have this system of equation which can be solved by hand easily, but I'm going to use the calculator here just so we can get used to. Right. Where's the calculator? here. Right. Sorry about that. Right. We're going to use row reduced echelon form. So second matrix, go to math, option B, reduce row echelon form, and then we write that to the matrix. So just pretty much do reduce row echelon form of the matrix. 1 for A, 1 for B, 0, 2A, minus 5B, and 7. Right. So pretty much we're going to do that. Alpha and zoom, that gives us the matrix. We go to 2 rows, 3 columns, click OK. 1 for X, 1, 1, 0, 2, a negative 5, and a 7. Let's have 1 and negative 1. So when we do that, we have the matrix of 1, 0, negative 1, 0, 1. Sorry, this is 1, this is negative 1. So first one is A, second one is B. So bottom line is the partial fraction of 7 over x minus 5, x plus 2 equal to A is 1 and B is negative 1. Right. So that is the partial fraction. Now back to the integral. Pretty much we just integrate both sides. Integrate this. Split the integral. I'll take the negative 1 out. Right. And now we use the first one, which gives us ln of x minus 5 minus ln of x plus 2 plus c. Right, there's maybe a different way to type this, but ln, the absolute values, make sure you enter the bar, or just click this button here. Ln of x minus 5 minus ln of x plus 2 plus c. Right, that's good. This is number 8. I'm just going to leave the calculator there. This time we do integral 196 over x cubed minus 14x squared. dx. So before we go any further, I will factor the denominator out, because after all we're going to use a partial fraction anyway. Right, here goes. Both of them have x squared at the bottom. Factor out x squared, x minus 14 dx. Right, first we do the partial fraction and then we integrate. (196) x squared x minus 14. Right, there's x squared, meaning 2 factor of x, so we need 2 fraction for it. Right, if the factor is linear, no powers, then we just need a constant on the top. If this is linear, just need a constant on the top. Right, multiply both sides by common denominator of x squared x minus 14. Right, that cancels out. 196, and then we have a x and x cancel out, we have an x left, and then x minus 14, x squared cancel out, x minus 14 cancel out. Right, multiply them out. Ax squared minus 14ax plus bx minus 14b, just multiply it out, plus cx squared. Right, combine like terms. X squared a plus c x squared that an x factor on x, and then don't need to underline anything, negative 14b. Right, 196. Right, they were just matching. We don't have any x squared on the left hand side, so a plus c is equal to 0. We do not have any x on the right hand side, negative 14a plus b equal to 0. At the bottom, negative 14b is 196. Right, we used reduced row echelon form to the matrix. 1 for A, no B, 1 for C equal to 0. Negative 14 for A, 1 for B, nothing for C, 0 for A, negative 14 for B, nothing for C, and 196. Right, so second matrix. Reduce row echelon form, alpha zoom to get the matrix. This one has 3 rows and 4 columns. Right, when we enter the numbers, do not hit the enter key until we're done just use the arrows to navigate. Ouch. 14. 1. -14. This we just do by hand, probably faster than use the calculator. 6. Of course, not there. Right. Close parentheses, and then so a is -1. B is -14, and C is 1. Right, put things together. We have the partial fraction of 196. X squared x minus 4 equal to A is -1, B is -14, and C is 1. Right, now back to the integral. Of the whole thing. So we split. I'll take the minus on the outside. -14 too. Ouch. For this, I will move x to the top, becomes -2. It is a lot easier to integrate that way. Right. Integral of 1 over x is ln of absolute of x -14. Integral of this is -1 to the -1, and integral of that it's just ln of x -14. Let's see. Finally, negative. (14x to -1) plus ln of x -14. Let's see. Right. Negative ln absolute value of x plus 14x to -1 plus ln of x -14. Let's see. Right. That's correct. By the way, if we want to, we can combine the logs. If we use that, we have ln of x -14 divided by x. If we enter this answer in MyMathLab, they will take it as well. So that's the nice thing about MyMathLab. They take equivalent answers. Let's leave there for a moment. Right, next. Still partial fraction. It's number 9. Evaluate. Right. Right. So first, there's a partial fraction of this. Right. So we have a factor, the linear factor and quadratic factor of multiplicity of 1. So we only need one fraction for each. The top, if it is linear, we just need the constant. If it is quadratic, we need a linear function. So degree on top is 1 less than the bottom for that. That is, of course, the repeated doesn't count. The repeated, we still have the same constant on the top there. So the power on the top doesn't affect. We just worry about what is the factor. So anyway, if it is a linear factor, we have a constant on top. If it is quadratic factor, we need the linear function on top. Right. Multiply by the least common denominator of x plus 1, x squared plus 1. Uh, 6x squared plus 5x plus 11. Right. Multiply it out. X plus 1 cancel out. X plus 1 cancel out, and x squared plus 1 cancel out. Right, multiply it out. 6x squared plus 5x plus 11. Ax squared plus a. Right. Ax squared all the coefficients have to be different. Right, so B and C, Ex plus C. Right, Bx squared plus Bx plus Cx plus C. Sorry about that. All the coefficients have to be different. Right. Combine like terms. A plus B for x squared and then B plus C times x and then A plus C Right, the left hand side 6x squared plus 5x plus 11. Right, matching coefficient. There's 6x squared on this side, so the coefficient must be 6. And 5x here, so the B plus C must equal to constant 5, coefficient 5, sorry. And then the 11 is A plus C. Again, we can do this by hand or using the calculator. I've just used a calculator. coefficient 1 for A, 1 for B, nothing for C, 6, 1 for B, 1 for C, 5, 1 for A, nothing for B, 1 for C, 11. Right. Second matrix, math, option B, alpha zoom, 3x4 matrix, 1 for A, 1 for B, equal to 6. No A, 1 for B, 1 for C, and 5. 1 for A, 1 for C, and 11. Right, 6, 0, and 5. So A is equal to 6, B is equal to 0, and C is equal to 5. So the partial fraction is 6x squared plus 5x plus 11 over x plus 1, x squared plus 1, 6 for A, B is 0, so there's no x, C is 6, C is 5, 5. And then we'll integrate. So we split the integral, and then we just split the integral. I will take out the 6. And the 5. Okay. Now bring back the formula. This gives us just ln of absolute values of x plus 1. And this gives us the tangent inverse. 1 over b. B is 1 in this case. Tangent inverse. X plus A is 0. B is 1. Yeah, so we have that. Again, section 8.5, subsection 2. Once we have those, will be very easy to integrate. That's just 1, that's just x. So we have 6 ln of x plus 1 plus 5 tangent inverse of x plus c. Right? Right. Next we will use the midpoint, trapezoid, and Simpson rule. Right. This is what we did in the morning. So let me find out what note that we have. So for this section, it will be very handy to have these rules. Right. I'm just going to write out midpoint rule. Using 6 subinterval. integral from 2 to 3, 2 times sine pi over 3 x dx. Right. So go from 2 to 3. First thing we do is find the width. Just delta x. B minus a over n. Three minus 2 over 6. 1 over 6. Alright, not going to be pretty. Go from 2 and 6. 1, 2, 3, 4, 5, and 6. Right, the increment is 1, 6. So if we're not sure about this, we just say 2 plus 1, 6, and 2 plus 2, 6, and then so on. Right. But what we have here is using the midpoint. So 2 plus 2 plus 1, 6 divided by 2. 2 plus 1, 6. And then divide by 2. So we have to find the midpoint here, which is 25 over 12. Alright, now we just take the midpoint, add those two, divide by 2, and just keep doing that. Now the nice thing about this is, since the width is 1, 6, we just add 1, 6 to this. Just add 1, 6, because that distance here is the same as distance between the midpoints, will be the same as the sample points. So I just plus 1 over 6. Now the nice thing about this is we use the answer plus 1 over 6. You see it turned out to be very nice. 9, 4. Just keep hit, don't have to do anything, just hit enter. They just keep adding 1, 6. And just hit enter, adding 1, 6. (11 over 4). Because the answer is the last one, all we do is just keep adding 1 over 6 into it. Right, so those are all the midpoints. Right, once again, the distance between two sample points is the same as the distance between midpoints. So when we have the first one, just add the 1, 6 into it. And just keep doing that. We have all those points. Alright, those are the midpoints. And the midpoint rule is the function evaluated at those midpoint multiplied by delta x. So this is very simple. First, I will store this number into a list. 25, 12, 9 over 4, 29 over 12, 31 over 12, 11 over 4, and 35 over 12. Store that into list 1. Right. Second parentheses, 25 over 12, comma, 9 over 4, comma, 29 over 12, comma, 31 over 12, comma, 11 over 4, comma 35 over 12. Close the curly bracket, store into list 1. Right, next we'll evaluate the function y equal to 2 times sine of fraction pi over 3 times x. Right, that is a function. Just make sure that it is in the radian mode. It is, which is good. Right, and then we just evaluate the function at list 1. So alpha trace y1 open parentheses second L1. And then we add all of this up. Second stat summation. Second stat, go to math, option number 5, and just add that up. And then at the end, don't forget, multiply by the width. We have this, multiply by the width of 1 over 6. Zero 0.9561. They said 4 decimal places, so 0.9561. Right, that's good. Again, the midpoint rule is 5 on the midpoint. Those are the midpoints. Evaluate the function, add all of them up. Add all of the values and then multiply by delta x. Right, 11. Trapezoid rule. I'm going to leave all the formulas there. Trapezoid rule for n equal to 6. And right, trapezoid rule says the first point and last point, the coefficient is 1. Everything in the middle is 2. But multiply by delta x divided by 2. Right. Keep that in mind. So once again, the interval is 6. 6 subs interval. Right. 0, 1, 2, 3, 4, 5, 6. From 0 to 2. What is the width? B minus A over N. Minus 0 over n 6 sub interval, so it's 1/3. So the increment is 1/3. So we just take 0 plus 1/3. So this is easy. 1/3, 2/3, 3/3. This is 1, by the way. 4/3 and 5/3 and 6/3, which is 2. That's fine. Right. So those are the values. Now the coefficient in the trapezoid rule. One for the left, one on the right, everything in the middle. There are 2 of them. So first I will store all these values onto a list 1, 0, 1/3, 2/3, 3/3, 4/3, 5/3, and then 2. Store that into list 1. Right. And then the coefficient, store that into list 2. 1, 2, 2, 2, 2, 2, 1. Store into list 2. Right. And then we evaluate the function. Evaluate the function at list 1. Before we add all them up, we will multiply with the coefficient. So that means 1 times the values of that, 2 times the values of 1/3, 2 times the values of the function at 2/3, and then so on. And after that, we will take the summation of that. And then multiply by, remember, trapezoid rule, delta x divided by 2. Right. So enter the function y equal to 5 times sine of a fraction of pi over 2x. Right, that's correct. Right, now enter the list. We don't even need to clear the list, just enter this on the top of the other. 0, 1 over 3, 2 over 3, 3 over 3 is 1, 4 over 3, 5 over 3, 6 over 3 is 2. Store that into list 1. Right, list 2 is the coefficient 1, 2, 2, 2, 2, 2, 1. Close and store into list 2. Before we go any further, I just want to hit the stat and edit. If we take a look at the list, it's fine now. One on the top, one on the bottom. So there's a corresponding between the two lists, which is good. Right, second mode. Right, evaluate the function alpha trace y1, and then second number 1 for list 1 times list 2. Right, so that's good. Now we add all of them up. Second stat go to option math, number 5, summation. Highlight that part times delta x, which is 1 over 3, and then divide by 2. Right, I have 6.2201, 4 decimal places. Right, so that is the trapezoid rule. The coefficient is that. Next one is the Simpson's rule. The Simpson's rule using 4 steps. For subinterval. Right. By the way, I'm not sure if the answer is this, because they might mean 4 steps differently than the way I call it in class. I guess I need to write a little bit bigger in case it's difficult to see, because this screen looks smaller than the regular one for lecture. So we go from 1 to 3 for subinterval. Right, first, as always, the width. Right, should work bigger. Three minus 1 divided by 4 is 0.5. Right. For subinterval from 1 to 3, increment by 0.5, so 1.5, 2, 2.5, and then 3. Coefficients for Simpson: 1, 4, 2, 4, 2, 4, 2, and then 4, 1 at the end. Right, and all we do is just store the numbers on the list. 1, 1.5, 2, 2.5, 3, store to list 1. And then the coefficient: 1, 4, 2, 4, 1, list 2. And then evaluate the function at list 1, those points, and then multiply by the corresponding coefficient, list 2, and then add all of them up. In the Simpson's rule, the delta x divided by 3, so don't forget about that. Right. So we start numbers 1, 1.5, 2, 2.5, and 3. Store that into list 1. And then we have 1, 4, 2, 4, 1. Store that into list 2. Evaluate the function alpha trace y1. Evaluate at least 1 times list 2. Right, add all of them up. Second stat, math, option number 5. Go up, highlight, copy and paste, times delta x, 0.5 divided by 3. Right, now that's good and all, except make the biggest mistake. The function is 4x plus 3. We should do that first. Sorry about that. Good thing this one's multiple choice, so that is way off, so we know it. Right, the good thing is we already entered the number, so don't need to change much. Alright, that is list 1. Good. Now list 2. I just do that again. 1, 4, 2, 4, 1, close. Store into list 2. And then alpha trace y1 times L2. So that's much better. And now we add all of this up. Can't even do that by hand. Sorry. Second stat, go to math, option number 5, summation, copy and paste, times 0.5 divided by 3. Right, 22. Oh, much better. Right. The next one is also Simpson's rule, but I'll let you do that. And next we have the improper integral. So we can put the calculator away. This is number 14. Evaluate improper integral negative infinity to negative 3 6 over x cubed dx. Right. Right. So first thing we do is, if there's infinity on the limit, positive or negative, we should change the limit to a number. The lower limit, let that be a. So go from a to negative 3 instead of negative infinity. So first thing in improper integral is to replace the limit. And then we just integrate. 6. The x cubed move to the top. Right, and then we integrate. I mean, we can integrate right in this step. Six. Integral of x to negative 3 is x to negative 2 over negative 2. Going from a to negative 3. Right? Right. 6 and negative 2 is negative 3. X to negative 2. A to negative 3. X to negative 2, if I move to the bottom, become x squared. Right. Now substitute in the numbers. Negative 3 in for x. And a in for x. Negative and negative. Subtract a negative, so it change to positive. Negative 3 over 9. Negative, so that's 3a square. Right. Finally, we put in infinity. Negative 3 over 9 is negative 1 over 3 plus 3 over negative infinity square. Right. We have a finite divided by infinity. So this goes to 0. A finite number divided by infinity is equal to 0. So I just say because of the finite divided by infinity. So we just have negative 1/3. Evaluate negative infinity to negative 8 dx over cube root of x. I usually move the dx on the back, so we clearly see the integrand like that. Now, there's infinity at the bottom, so we will have to write the limit for that. A go to negative infinity. At the bottom, there's a. On the top is negative 8. Right. This x cube root of x, let's write that as x to the 1/3. It will be easier to integrate that way. Right. Now we have this. move the 1/3 from the bottom to the top, it becomes -1/3. Right, now integrate. Be x to the 2/3 over 2/3. Going from 8 to -8. Right, -1/3 plus 1 is 2/3. Right, divide by 2/3 is multiplied by reciprocal 3/2. Right, and now let's put the limit in 3/2 -8 to 2/3, subtract 3/2 a to the 2/3. Right. What is -a to the 2/3? -8 to the 2/3. Right, that's 4. And then 3/2 a to the 2/3. Right, 3 times 4 divided by 2, that is 6, minus 3/2. Now if we put in infinity in for a, infinity to the 2/3 is still infinity. So in this problem we have 6 minus infinity. So it's not going to be any finite number. Because of that, this problem we say the limit does not exist, or we say it is divergent. Or the integral diverges. Wow. Evaluate -infinity to infinity of dx over x squared plus 49. Right. First, move the dx to the back. By the way, this looks very similar to the problem we did in class. Right. So I'm not going to do that. I will let you do it. Right. See section 8.9. Subsection 1, C, example 5. That's very similar to the note, so I'm not going to do it. Right, moving on. 17. Evaluate. Right, the top is E. negative infinity to e 10 e to negative x dx. Does that look like a typo or something? That's e. Right, doesn't matter. Let's just do it anyway. Right, I think we did kind of similar as we did in class, but anyway. So first thing we do is replace the limit. The bottom limit, so let that be a. I'm still why they put e here, no idea, but I may have something going here. Right, integral of e to negative x is e to negative x divided by negative 1. Going from a to e, e to the kx dx. Integral of that is just e to the kx divided by k. Let's see, it is in section 8.2, iteration by parts. We review all that. Ten divided by negative 1, negative 10, e to negative x, from e to a. Now I see why they have a, why they have e. Right, put e in. Right, that might look strange, but don't worry about it. Right, that gives us negative 10 e to negative e plus 10 e to negative a. Right, now we put negative infinity in here. This doesn't matter at all because this term go to infinity. So we might have some weird number here, but we add infinity, so the limit still does not exist. So this is divergent. Right. Evaluate. Zero over pi over 30. Tangent 15x. Right. This problem is still evaluate improper integral. So it's proper integral, meaning there's something wrong with the integral itself. So obviously there's nothing wrong with the limits, or it seems, right? So because we don't have infinity, so we don't know what to replace, but we have the function of tangent 15x. Now if we actually want to see, we have to put anything from 0 to pi over 30. Let's put 0 in here. Let's do some quick check. Tangent of 0 is 0, which is fine. Now tangent of, put pi over 30 into it. Right, let's say we still have radian, right? Tangent pi divided by 2. Oh right, it's undefined. So in this problem, the interval that we integrate cannot include pi over 30. So we just put the parentheses around it. Right, so there's a problem with the interval, and in particular the upper limit. So let me rewrite the problem. Right. Now if we go between 0 and pi over 30, this is only on the left side of it. So that is only on the left side of it. So we have to fix this, write that as, say, the upper limit. Let's use b for that. Zero. Right. The integrate of tangent is secant square. So wait, sorry. Integral of tangent. Oh boy. Is ln of cosecant. ln of cosecant of 15x. There's a point we replace this by b, right? So why don't we use b here? Right. Should write tangent is ln of secant right. And now tangent of 15, we just divide by 15. Integral we divide by, so sorry, 1 over 15 ln absolute value secant of 15x. Right. Now put in the values. secant 15b minus 1 over 15 ln secant 0 secant is 1 over cosine Now we put in pi over 30 cosine 0 is 1. So this is equal to 1. Cosine 0 is 1. 1 over 1 is 1. Cosine of 15 times pi over 30. Cosine pi over 2, which is 1. I'm sorry, 0. But this one from the negative sign. So what happened? So, well, cosine pi over 2, but from the negative sign, so we subtract a very small number. So it end up with being positive, very small. Right. Really disappointed after all of this. We have ln of 1 over 0 when we write like that, we don't even need the limit anymore. One over 1. So we just have that. We already calculate this. 1 over 0 is going to be infinity. Ln of infinity is infinity. And in this case, we just have infinity minus 1 over 15. And after all of that, this is still divergent. Right. Number 19. Right. There's also improper integral. So what's wrong with that integral? Right, the function itself, the limit 0 and 1, there's no problem with it. Now we try to put 0 and 1 in and see what happened. And obviously if we put 1 in, this is the big problem. So when x equal to 1, x squared over x cubed minus 1 is undefined. So in that case, we have to fix that. Now if it goes from 0 to 1 and 1 is where there's a problem, we have to avoid it. And it goes from this sign on. So fix that on the left side. Right. And now usually when it looks like that, it looks like a partial fraction, but we don't have to go through all of that, because on this one, x squared and x cubed, if we let u equal to x cubed minus 1, that is the derivative. So a simple u substitution will work. But before all of that, I'll replace this with something else. We have dx. Right. Also the limits. When u equal to 0, when x equal to 0, u equal to 0 cubed minus 1, so it's minus 1. When x equal to b, u equal to b cubed minus 1. Right, so we change the limits. And when we do all of this substitution, we will have the limit will change to -1 and b cubed minus 1. X squared is still there. X cubed minus 1, we let that equal to u already. And the x is this. Limit change from x 0 to 3 to u -1 b cubed minus 1. Right. The reason this substitution works because there's no more x. If there's x left, we have to try something else. We have the 1 cube, 1/3 outside, the 3 on the outside, and everything seemingly fine. We just have 1 over u du. Right, it's 1/3. 1 over u integrals ln of absolute values of u 1 from -1 b cubed minus 1. Right, put those in here. One third ln of b cubed minus 1. Right. B goes to -1. And we have this 1/3 ln of b cubed minus 1 minus 1/3 ln of absolute values of -1 is 1. ln of 1 is 0. Right, at least we only need to worry about this. So we only have 1 over 3 ln of 1 negative cube -1. Right, let's try to do that. We have 1 from the negative side, so we subtract a very small number cube and then -1. Right, that is negative, very small number. We still have infinity though. We still have the absolute values. That's what I mean. We have a very small number that is negative, which is ln of 0 plus. So the ln function, when x goes to 0 plus, the ln goes to negative infinity, which is divergent. Right, by the way, it is because on the review we have divergent, doesn't mean on the test it will be divergent. It just happened here that it is divergent. Right, so it's about 2 hours. I'm going to pause the video real quick and then check to make sure that everything's good. Then we'll continue. We are back. Look like there's no problem at all with the video, so we continue here. Now we go to chapter 10. This problem 20. Right, several terms are given. So we have 1, -749, -343, 2401. Right, I'll find the next two terms. Obviously on here what we see is we just multiply by -7 to get to the next term. So the next two term is 2401 times -7. We still need calculator here. 2401 2401 times -7. So the next one is at the sixth term. Is -16,807. and then the seventh term just multiply by -7 again. 117,649. Right, I try that. -16,807. Next, 117,649. Right, that's good. Right, so which one? So pretty much what we see is this term, I mean the next term is equal to this term times -7. So I will go with C. To get to the next term, we take this term times -7. Right, that's good. And now to find the explicit formula. B is recursion. In order to get to the next term, we take this term times -7, where the first term is 1. We have to know where we start on the sequence. Right, C. Right. A nice thing about this is we just have -7, -7. So think about this. If we have the n term, let's say I just write the first term is 1, the second term 1 times -7, the third term 1 times -7, that, and then we times -7 again. Bottom line is we see the pattern. We just keep multiplying -7. To get to the second term, we need 1 of the -7. To get to the third term, we need 2. So in order to go to the n term, we're going to need -7 to the n minus 1. So check n minus 1 of the -7 to get from here, from get to 1 to that particular term. We don't even need to type 1. We just say -7 to n minus 1. Right, that's good. We have 0.7 to the n power. It will be very simple if we just take a look at this function. 0.7 to the x power. And what we see there is the function approaching to 0. So we say limit of 0.7 to the n power as n go to infinity is equal to 0. Because it's just decreasing. If we have something bigger than 1, it is increasing. So exponential function, the base is less than 1 is decreasing, greater than 1 it is increasing. So this is less than 1, so it is decreasing. Even though it is decreasing, but it cannot be negative. So we could imagine that it gets smaller and smaller, but still positive. Essentially, it goes to eventually it goes to 0 at infinity. So this converges by monotonically, and it converts to 0. That's simple enough. Right, the next number, 23, we have the sequence of -3.4. Now this is, in terms of magnitude, is bigger than 1. what happens if we have that? Negative 3.4 raised to the x power. It might look weird here. Do you see anything? Nope. Maybe need to change to something. It is bigger than 1, so let's just say to 1.4. Maybe it's easier to see. Where are the points? Right. You cannot do that. Just have to do it by hand. Make a table. We don't need to do this by hand though. Just hit second graph and look at the table. When x equal to 0, this is 1. X equal to 1, negative 3.4. X equal to 2, 11.56. 3, negative 0.39.3. What we see here is as x increasing, it starts from 0 and 1. And then at 1, at 2, at 3, just keep getting out of control. Just the bigger x is still just alternate between positive and negative. So this is the sequence. So we only worry about the integral. I mean the integer values of x. So this one is diverges by oscillation. Oscillation is kind of changing alternatively. So if it is bigger than 1, right, let's just summarize here. There are 4 cases. If we have a base to the n, going from 0 to infinity, right, there will be 4 scenarios for that. If b is between 0 and 1, like we're talking about this sequence, this one will go to 0 and the base is less than 1, so it is decreasing. Like the first example we have on number 22, decreasing, and this is divergent. If we have b greater than 1, like 1.5 here, the base is bigger than 1, it is divergent and increasing. Now if b is less than 0 but still bigger than negative 1, think about like 0.5 negative. This one still go to 0. Sorry. If it go to 0, that is convergent, not divergent. All right, just think about the numbers. This one, it will go to 0, and this is oscillation. How to spell that? And if it is less than negative 1 completely, it will be like negative 1.5 to the n power. This one is divergent and also oscillation. Alright, so bottom line is whenever we have a negative, that is oscillation. and when n is positive, it will be increasing or decreasing, or what we call the monotonic. And in terms of convergent and divergent, anything between -1 and 1 is convergent. Yeah, so those two are convergent, go to 0, and on the outside will be divergent. Right. I'm sure we'll talk about that more on the section 8.1. Next, this one is 23. Wait a minute. Just named the number wrong. This is 21 and 23. 22, sorry. Now we'll go to 23. So negative will be oscillation, and then positive either increasing or decreasing. Between -1 and 1, convergent, outside divergent. I'm sure I will emphasize that on the section 10.2. Find the limit of the sequence. So the limit of the sequence is kind of the same as of the limit of a function, except in the sequence we have n instead of x. But all the rules that apply for function in terms of limit still apply for sequence. So find the limit of that. So pretty much we just take the limit when n goes to infinity of that. Right, so when we look at this, when n goes to infinity, 5 to the n plus 1 is extremely big. So when n goes to infinity, this one is a lot bigger than 5, right? So as n goes to infinity, 5 to the n plus 1 is a lot bigger than 5. So if it's too big, we just drop it completely and nothing changes. Right. And then we divide, meaning we subtract the power. I don't know why I do that. As soon as I write down it, I know that it's terrible. So subtract the exponent when we divide. I usually use pencil, but pencil is very difficult to see under the document camera. So n and n cancel out, just 5, so this is just 5. Right. Right, also next one. I'll find the limit of that sequence. Right, this is kind of classic problem. So pretty much we find the limit at n go to infinity. Right. So both n at the denominator and n on the top. So first thing, let's put infinity in and see what happens. So this looks like 1 to infinity. This is indeterminate. By the way, I think go back to section, I think 7.6. That's why we did this. So what we have for this problem, what we do is we're going to let this equal to y, and we'll take ln on both sides. The only reason we take ln is so that the exponent can bring it down. That's good. Now this is indeterminate form, right? And associated to indeterminate forms is the Harper rule. So in order to use the Harper rule, we need a fraction. So in that case, whether we move the n to the bottom, become n to the -1. And on the top we have ln of 1 plus 16 n to -1. Right. Now that's better. Now we can use the Harper rule. The Harper rule. So we take the derivative on the top. The derivative of ln is 1 over and then derivative, what's left? I mean what inside the parentheses. Derivative of this is negative n to -2. Right, that part's easy. And now we have 1 plus 16 to n minus 1. And same thing. Right. So we have 1 over 1 plus 16 to the n minus 1. Derivative of this is negative 16 n to -2. And negative n to -2 at the bottom. So both of them cancel out, even the negative sign. So when we put things together, it will be equal to limit when n goes to infinity. We have 1 on the top, 1 plus 16 to the n minus 1 at the bottom. Also on the top, 16. Right. So we have limit n goes to infinity, 16 on the top, Let's write this as n at the bottom. Can always do that. Now 16 over n, 16 over infinity, when n go to infinity, go to 0. So that one go to 0. Bottom line is we have 16 over 1, which is 16. So n go to infinity of 16, and ln of y is equal to 16. To get rid of the ln, raise both sides to the e power. E and ln cancel out. So y equal to e to the 16 power. So that is the limit. So similar to the problem we did in section 7.6. Right, again, we let y go to the limit when n goes to infinity. Because of that, we have to take ln on both sides, so bring down the power. When the power is down on the same level, we still need to bring that down to the denominator because we need a quotient to use the Improper rule. When we take the derivatives of the top and the bottom, simplify, and we end up with 16, and e and ln cancel out. We have e to the 16. Also find the limit of the sequence negative cosine of n over 2n. Right, so what happened when n goes to infinity? Of negative cosine of n over 2n. Right, this is actually easier than we think. So first of all, cosine of n is between 1 and negative 1. Actually, cosine of anything is between negative 1 and 1. Now we have negative. If we multiply everything by negative 1, negative 1 becomes 1, 1 becomes negative 1. But when we multiply by negative, we switch the inequality. Bottom line, we still have negative cosine is still between negative 1 and 1. So, good. We have negative cosine is between 1 and negative 1. Same thing as cosine, same thing as negative cosine. Once again, multiply by negative number, reverse inequality, which is still between negative 1 and 1. Right, now, what happened when we divide by 2n on both sides? Now, since n goes to infinity, we divide by a positive number, inequality will not change at all. However, as n go to infinity, this go to 0, and this go to 0. And one thing that we forgot from the beginning is it could be equal to. Right, there's a reason I need to do that. So the Swiss theorem, this is a Swiss theorem, works out perfectly. If the left side go to 0, the right side go to 0, the middle has to go to 0. Right? So the equal sign is essential. We do need the equal sign. Otherwise, it does not work. The square theorem requires to have the equal sign, so it should have the equal sign there. So the limit of cosine of n over 2n is equal to 0. This is the square theorem. The left goes to 0, the right goes to 0, the middle has to be 0 as well. Evaluate geometric series. Right, so geometric series. They use k, so we use k as well. So a constant a times r to the k power is going to be equal to a 1 minus r. This is only if r is between 1 and negative 1. Not even equal. And this one is divergent. If r is not between here, or usually we just say it otherwise. Right, so geometric series is that. So our problem, what do we have in our problem? Summation from 0 to infinity, 11 over 12 k. Right, a coefficient just 1, so we're going to have 1, and the ratio 11 over 12 is between negative 1 and 1, so it's good. One minus 1 over 12 is 1 over 12. Divide fraction is multiplied reciprocal. So this is just 12. So very straightforward for the geometric series. The sum of the geometric sequence that goes to infinity. Right. We have more of this, but still same formulas. Right. So, this is about 1.5 hours into the review. And don't worry about on the test, I'm not going to ask you 35 questions like here. The test usually, my favorite, it's just like about 20 questions, still have 2.5 hours. Right. Notice that the formulas here is not the same. So actually have to write out if we need to. If we put 2 in, the first one we start 2 with the 5 square. And then next I'm going to put 3 in. And then next, put 4 in. So actually, all of them we can factor out 2 over 5 squared. Should be like that. Bottom line is, if we have to write this as a series, it have to be some change. Never mind. I think it will be better if we make the change like this instead. Right, so we need to go from 0, right? So how do we do that? If this need to, how do we change this to 0? Right, so in that case, if we have 2 and we want to be 0, so why don't we just subtract 2? So we let k be m minus 2. In that case, k is going to be 0. I mean, if m starts from 2 and we don't want that, subtract 2, get back to 0. So let k equal to that. So plus 2 on both sides. M k plus 2 equal to m. Now try that substitution. M is k plus 2. M is k plus 2. Now for this, if we subtract 2 on both sides, we have k equals to 0. Right, so we'll do this, we can shift the index easily. Now what do we do with this? What we can do is, why don't we write 5 to the k plus 2 is 5 to the k and 5 squared. You can just forget about that. This is what we do. Right. Now we just rewrite this. First, these two terms doesn't have k in it. We have 2 over 25. And then we have 1 over 5 to the k power. So we can write as k goes from 0 to infinity. 2 over 25. Now 1, we can say 1 to the k is still 1. So put 1/5 inside the parentheses. And this is a lot easy to simplify. 1/5 is the ratio between -1 and 1. Between -1 and 1. So that works out perfectly here. We can use this formula. So this sum is equal to, the first term is 2 over 25. The ratio between -1 and 1, so minus 1/5. 2 over 25. 1 minus 1/5 is 4/5. Multiply reciprocal. Five and 25 cancel out. We have 2 over 5 times 5, 25 cancel, 2 over 20, which is 1/10. Right. So when we don't have the series start from 0, make the change. So that will start from 0, and we can use the formula easily. Right, we want to write this as a geometric series. Zero point 0.04 repeating. So that means like that. Right, so how do we do this? If we want to write it one, two, three, four, 1, 2, 3, 4, 5. We certainly can do that. So this is the first term in the geometric series. This is A. This is A times R. This is A times R squared, and so on. Our geometric series works like that. The first term is 0.04. And the ratio is easy. How do we get from this term to the next? So if we multiply by, in this case, 0.01. So when we write like that, we know the first term is 0.04 and the common ratio 0.01. So the summation is just A R to the n, and for some reason I just switch from k to n. Let's keep with k then. So that's very simple. K from 0 to infinity. This is a geometric series. The first term 0.04, the ratio. It looks like this. Right. And then turn this into a fraction. And the ratio is between -1 and 1, so we use the formula A over 1 minus R, because the ratio is between -1 and 1. A 1 minus R one minus that is 0.99. Move the decimal place two places to the right. 4 over 99. Right. By the way, the calculator will know that as well. If we just say 0.04, sorry, 0.0404 have to be extremely long number. If we keep doing that, convert to fraction, And of course, that's what we have. Next, find the following telescoping series. Find the formula for n term, and then evaluate when s of n goes to infinity. So pretty much we will evaluate this particular as telescoping. Right. A over k minus 8 over k plus 1. Right. Let's just write a few terms and see what happened. Right. Put 1 in for k, a over 1 minus a over 2. Right. Now we're going to put 2 in. A over 2 minus a over 3. Now put 3 in. A over 3 minus a over 4. Now do that and we put n in. A over n minus 8 over n plus 1. It is called telescoping because it cancels everything. And the next one, of course, we cancel that one too. Pretty much we only have the first term is 8 and then 8 over n plus 1. So this is if we take n terms. A minus a over n plus 1. Right? That will do. Right, what happened if we take this limit go to infinity of that series? So what happened if we put infinity in here? Right, what we have is 8 over infinity plus 1, 8 over infinity. A finite divided by infinity is 0. So that one go to 0 and we just have 8 minus 0. So just 8. Yeah, once again, finite divided by infinity is 0. The next is also telescoping, but we need to do something first. Right. So we have that. So kind of like the integral, when we have something like that, it is like partial fraction. Try to split that into a little fraction. Perhaps we have a telescoping series after that. Right. Write this as a partial fraction. Right, multiply by the common denominator. And an n cancel out. And then plus 3 cancel out. Multiply them all out. A times n, a times 3, and then b n. Right, combine like terms. Right. It's not anything nice and even, but so 5 is equal to 3a and a plus b is equal to 0. And a plus b equal to 0, and obviously a is opposite side b. So back to the sum. Later on we can see that this one is convergent. We need to find the sum. Alright, let's split. Five-thirds for a. Five-thirds. Negative 5/3 for b. I'm going to take the 3 down to the bottom. Take the minus here and the 3 down to the bottom. Right. Five over 3n minus 5 over 3n plus 9. Right. Now let's write the first few terms. Maybe we see something here. Put 1 in for n, 5/3. Put 1 in for n. Will be 12. Right. Doesn't lead us anywhere yet. Next, put 2 in for n. And put 2 in for n. 3 into 6, that's 15. Still nowhere yet. Put 3 in for n. It's going to be a while. 3 times 3 is 9, so that's 18. And then put 4 in for n. Four will be 12, 21. This look like help. Keep going. Where are we? 4, right? Now put 5 in for n. Uh, 15 and 9, 24. I'm not going to do that anymore. Is there anything simplify? Oh, okay. That doesn't do anything. Look like this. Right. That doesn't do anything. But the 15 does cancel out. That doesn't do anything. If we keep going on the negative, will cancel out. And the negative here will cancel out. So all the negative will cancel out. And the positive starting from there will cancel out. So after all of that, we only left with 5 thirds, 5 6, and 5 9. 5. If you write out a lot more terms, then you will see the pattern. Those 3 terms will stay, everything else cancel out. So it's sort of like the telescoping series, but they not cancel right away, but it takes some time to write out the terms. (55/18). Right, so we have to do the partial fraction first. I'll use the divergent test. Right, the divergent test, by the name of it, it only tests for divergence, cannot test for convergence. Right, I brought the right out. Now, if the n term goes to 0, it is inconclusive. But if the n term goes to something else, it have to be divergent. Just by the name of it, it only tests for divergence. Now that is rather simple. If we're talking about the series, we have a very long series. If the last term does not go to 0, this series just keep changing. We'll have to have the last term that goes to 0. I mean, when n go to infinity, the sequence approaching to 0. Even when it goes to 0, it's still inconclusive. But if it's not equal to 0, then that will be divergence. Only test for divergence here. Now this one, they only want to test for the divergent test. So what all we do is just take the limit. Go to infinity of that term. Now this is more like Cal 1 problem, except in Cal 1 we have x instead of n. So when n go to infinity, only the highest power terms matters. And we cancel out the n. So we just have 1/11 times n. Now, when we put in infinity for n, 1/infinity, finite over infinity is equal to 0. Now, if it is equal to 0, it is inconclusive. There's a lot more way to test this, but for now, if we use the divergent test, it is inconclusive because the sequence, the n terms, go to 0. If it goes to something else, then that will be divergence. Oops, I think we passed it. 32. Already. I started like 3-4 hours ago and didn't think I could get this far. Don't worry, on the test I won't ask 35 questions. It's just about 20 questions, and it should be reasonable. You still have 2 hours and a half. And besides, you don't have to recall where you do it. Right, so the divergent test, still the same thing. If the n terms go to 0, inconclusive. If it go to something else, divergence. Of course, there's something that require that to be positive and all other things, but don't have to worry about that. Actually, I should go to there. Yeah, so that is the divergent test. Anyway, so we just take the limit. We have k, doesn't matter if it starts from 2 or any numbers, because we only worry about when it goes to infinity. Let's put the parentheses here so it's easier to see. Right, now let's put infinity in it. Ln of infinity is still infinity. So infinity over infinity, that is indeterminate. Right. Which means we're going to use the Hospital rule. I'll take the derivative of the top. Just 1. The derivative of Ln is 1 over, by the chain rule, derivative of the parentheses, which is 10k, 10k. Right, 1 over 10k. Derivative of 10k is 10. 10 and 10 cancel out. We just have 1 over 10. Sorry. One over k, just divide fraction, multiply reciprocal, so just k, and obviously this goes to infinity. Since this is not equal to 0, this is divergent. Right, the divergent test, because the limit is equal to infinity. Right. So it's either divergent or inconclusive. We cannot test convergence here. So when we look at these choices, if we use divergent test, it's not going to be convergent. So it's not going to be B for sure. Right, now this is the integral test. So on this chapter, actually we have like 10 different tests, and it would be nice if we know when to use what. Right, integral test. Actually, we need to check a few things before we do the integral test, and the integral test is over there. We need to check to make sure that continuous, positive, and decreasing, these three things. So continuous, positive, and decreasing. We know it's going to be true because if none of this works, if one of this doesn't work, we cannot use the integral test. If we use the integral test, all of this have to check. So obviously it is continuous because when we start from 0, this is positive. We don't divide by 0, so it's continuous because it is defined. It's good. It's positive. Start from 0, it's definitely positive. And then decreasing. Usually if we use calculus 1, decreasing is derivative, is negative. But in this case we say decreasing because think about it this way. We go from k and we're increasing values for k. If we have a number, the bottom is keep increasing, then the whole thing have to be decreasing. If we're increasing the denominator, the whole thing decreases, right? Yeah, so we only need to verify that. Having said that, it has to be true for all of them. Otherwise, the integral test will not work. So in terms of integral, instead of doing this, we just integrate. Let's use x instead of k. And we go from 0 to infinity dx. Oh, in the note it said 1. It doesn't matter. Right, just integrate. Improper integral, section 8.9. So there's infinity here. So make a substitution. Upper limit, so let's use b. Right, we use substitution here to evaluate this integral. Go from 0 to... Right, substitution. Let u be x plus 3. I will take derivative. Equal to 1. So du is equal to 1 times dx. Just move the dx over. Right. Changing the limits 0 to b. X equal to 0. U is equal to 0 plus 3. X equal to b. U equal to b plus 3. Right. So this integral the limit changed from 3 to b plus 3. 2 over square root x plus 3 is u, dx is du. Infinity. By now we know that this is written as 2 over u to the 1/2 du. We know that if the power here is bigger than 1, it will be divergent. So we know that this one is divergent already. But let's finish it. U to the 1/2 and then we integrate. U to the 1/2, negative 1/2, increase power by 1, divide by the same thing, from 3 to b plus 3. Okay. Multiply reciprocal, divide by 1/2 is multiplied by 2. Almost there. For u to the 1/2, 3 b plus 3. Right. Put in b plus 3. Right, that of course has some values, but when we put in infinity here, infinity to the 1/2 of course equal to infinity, so this term go to infinity, therefore we have infinity minus 4 times 3 to the 1/2, and of course that is divergent. If the integral is divergent, the series is also divergent. So the series is divergent because the integral is divergent. Oh, there's an option say the integral test does not apply. Right. And that equal to infinity. Right. So for integral test, we actually have to check these 3 things. Right. The next one is also integral test because we can integrate. By the way, this looks awfully similar to the one we did before. I'm talking about this one. This one, if we use the integral test, might be different, but the divergent test is inconclusive. So, when we do this, using the divergent test, it will be inconclusive. So the divergent test doesn't help. So actually we have to use the integral test here. Later on there will be a lot easier way to do it, but for now have to stick with the integral test. This is 34. test the series for convergent or divergence. The reason I think this could be a good test for integral test. Actually, integral test is never good. If there's a better way, it will be better. Integral test usually is not the best option. Because the reason that integral test may be an option here, because when we let u equal to the denominator, we have du on the top. So look like we can integrate. That's why we use the integral test. Right. So I have to be continuous, positive, and decreasing. Right, continuous. Obviously, if we put 1 or any bigger than this, the denominator is not equal to 0. We don't divide by 0. It will be continuous because it is defined. Positive. Definitely it is positive because we only put positive numbers in. Is that decreasing? It is. However, the way we determine this is, think about this way. If we have to show that this one is decreasing, we have to take derivative. If the derivative is negative, it will be decreasing. Right. Or we just check real quick. Maybe help. Right. How about we just graph? We use x instead of k. X squared x cubed plus 3 right. Now focus on this part only. I'm going to zoom out this part because k is only from 1 to k only from 1 to infinity. I'm going to zoom this portion of the graph. Right, slightly there's a problem. So at 1 is here and 2 is here, but after that it will be decreasing. Yeah, so it's increasing a little bit slightly at that point, but after that it will be decreasing. So we don't care about first few terms. It is decreasing. That's good. Right, let's integrate. Even though it's slightly increasing on the first term, but we're not worried about that. After that, it will smoothly decreasing. Right, let's use 1 to infinity and use x instead of k. Right. The problem with infinity, sure, change the limit to b, right? Next, we use substitution. That's a cube. Take derivative. Move the dx over. and then divide by the 3x squared. Now the limits. X go from 1 to b. Put 1 in for x. 1 cubed plus 3 is 4. Put b in for x. So we go from 4 to b cubed plus 3. Now it go from 4 to b cubed plus 3, and then x squared over u dx is du over 3x squared. X squared cancel out. Also take the 3 outside. One third. Integral of 1 over u is ln of u, ln absolute values of u, for b cubed plus 3. Now we put in the b cubed plus 3. And then the 4. Right, if we put infinity in for b, then we don't need the limit anymore. Ln of infinity is infinity, because the ln function go like this. So when x goes to infinity, ln of x goes to infinity. So we have infinity minus that number, which is infinity. So divergent test, if this is divergent, the series also divergent. So the series diverged by divergent test. And it's going to be infinity. Oh. Oh no, sorry. By the integral test, it is okay. This one. The series is divergent because the values of the integral is infinity. Right. Next one. Oh, that's the last one. Eight for root of k. Right. By the way, this is actually very easy. We just factor out the 8. and this we write as 1/4. Now this is a P series where P is equal to 1/4. And when P is less than 1, it is divergent. Equal to 1 is also divergent. Of course, the integral test also works, but using the P series is a lot easier. Yeah. So that's what we have. Right. Right. So that's the review. I didn't know it take like probably 3.5 hours. Sorry about the first 4 questions. For the first 4 questions, I have to go back and change a few things. Pretty much, it should be x equal 2 and not u equal 2. But other than that, it's fine. I also will change number 3, so the answer will look like this too. Anyway, for those of you who watched the whole review, well, there's no way I know that you did, but that about 3.5 hours. Still not my longest video. Some like 2 years ago, when I started have the YouTube channel, I have the review for the final, I don't know, about 4 hours. Right. But anyway, so I hope you find this video helpful. Thank you for watching.